In computing, we use a number of different units and symbols for storage, whether that be RAM or a hard disk or an SD card. And so in this video, we're going to look at these units. So the first most basic unit that we have is the bit. And a bit is either a 1 or a 0. And we use the symbol of a lowercase b. And its size is obviously just 1 bit, and so that will be a 1 or a 0. A nibble is a rather strange size that we use, and this doesn't have a symbol, it's not used quite so often, and the size of a nibble is 4 bits. It's also half of a byte. The next symbol which we have is the byte itself, and this one we use a capital B for, and that is 8 bits. Moving up, we go to a kilobyte, and kilo normally means 1,000, and it's very closely related to 1,000. The symbol which we use is capital K, capital B, and the size of it is 1024 bytes. Now it's a rather strange number, but computers work with powers of 2. 2 is the magic number in computers. So if we look at the number which is 2 to the power of 10, that means 2 times 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 2, so 10 times the 2's. If we look at what that results in, it's 1024 bytes. And if we look here, that's very close to 1,000, so that's why we use kilo or kilobyte. We then have a megabyte. This one's quite easy because the letter M, which we use in MB, stands also for 1 million. So if we look at how big that is 1024 kilobytes this time, which is the same as 2 to the 20s. That's 2 times 2 times 2, 20 times. And that number there comes out a very strange number, which is 1048,576. And if we look here, if we just put in some commas to help, that is just over 1 million. So we use the unit of a megabyte, which would mean 1 million bytes, but it actually means 1024K because of this 2 to the 20 thing. Then we've got gigabytes, and a gigabyte is GB, and that is 1024 megabytes, or 2 to the 30. And if you do 2 to the 30, you get a massive number, which is 107,37418, and it just goes off the area there to 4. And if we just put in the commas, we see that that's very, very close to 1 billion. And I'm keeping on doing these calculations and putting in these numbers just to show you how big these numbers are. This is 1 billion. So there's 1 billion bytes of information and approximately 8 billion bits of information. So 8 billion ones or zeros there. And the final one that we're going to take a look at is the terabyte. This one has TB as its symbol. And T is another easy one to remember because it stands for trillion. So it's 1024 gigabytes, or 2 to the 40 this time, which comes out an absolutely gigantic number of 10995,116,2776. And nobody actually remembers these numbers. I've already looked them up, of course. People will remember the 2 to the 40, they will remember that it's 1024 gigabytes. If we just look at this number and put in some commas, then we go like this, and there we're just over almost 1.1 trillion. So if you have a hard disk, for example, that's 1 terabyte of data, that's 1 trillion bytes, or just over 8 trillion bits of information. So 8 trillion ones or zeros can be stored on that one small hard disk, which is an absolutely phenomenal amount of storage. And that basically is the units of which we use in computing for storage.